This section goes with section 8.4 in your textbook. The topic of this section is the slope of a line for a linear equation. First, the big idea in this section is that slope shows a ratio of the rise of a line, that is how much it goes up, to the run of a line, how much it goes over. In the picture at the right, you can see that the black line is slanted in an upward direction. It goes up 6 feet from the front to the end of the line, and it goes over 10 feet from the front to the end of the line. So the rise of this line is 6 feet, and the run is 10 feet. The slope is simply the ratio of the rise to the run, so it would be 6 over 10. We will put specific numbers to the slopes of lines to measure exactly how steep lines are, but we'll also put some vocabulary terms to tell us in general what direction the lines are heading. What's shown here, and it looks like a person climbing uphill, we'll describe as a positive slope. The next picture, shown as a person walking downhill, we'll describe as a negative slope. The third picture, of a person walking on what appears to be a flat surface, this is a zero slope. If we think about it, that flat line has no slope. It doesn't go up, it doesn't go down, it is a flat line. And the last one, where we show someone falling off of the line, will have an undefined slope. I'll show you later on in this presentation exactly how we get numbers to go with 0 and then what undefined slopes look like when we try and calculate them. So first, let's learn a little bit about how to calculate the slope of a line. Here's a step-by-step set of instructions if you're given a graph of a line and 2 points on that line. So if we have the graph of a line, we can pick any 2 points on the line and use those to find the slope. Here's an example of a line shown in green. The first point on this line is the point 5, 4. The second point on this line is the point 3, 1. Step 2 in this example is that we're going to show the rise and the run. So the rise in this case, to get from one point up to the other, we would have to go from 1 up to 4. The run in this case is how far left and right we have to go to get from one point to the other. In this case, we have to get from 3 up to 5. Step 3 is we have to actually count the number of steps in the rise and the run. So in this example, we'll look at the rise and we'll see that we would have to go up by 3 steps. So the rise is 3. And the run, we would have to go over by 2 steps. So the run is 2. Notice that the rise is going up, so the rise is a positive number, and the run is going to the right. It's like it's going in the positive direction on a number line. So the run is also a positive number. Rise and run can both be negative. If we have to go down to get from one point to another, or if we have to go backwards, that is moving to the left on a number line, then the rise or the run would be negative. Step 4 is we're going to plug the values for rise and run into the slope formula. The slope formula simply says that slope is equal to rise over run. So in this case, we'll plug in a 3 for rise and a 2 for run. So the slope is 3 over 2, or 3/2. I encourage you to leave slopes in their fraction form whenever you can. The nice thing about the fraction form of a slope is that you can see the rise is the numerator, that's the number on top of the fraction, and the run is the denominator, the number on the bottom of the fraction. If you were to convert this fraction, 3 over 2, into a decimal, it would become 1.5, and you can no longer tell what the rise and run are from that decimal. Again, leave your slopes in fraction form when you can. Now, I'd like you to practice. Shown below are 2 lines, and on each line, we've identified 2 points. First, describe the slope, positive, negative, 0, or undefined, and then below, actually calculate the slope. Please pause this presentation while you complete this section in your notes packet. When you finish completing these problems, you can resume the presentation. I know many of you are feeling at this point like the person in this cartoon, as though your brain has imploded. You're doing well. Keep going. You're a little more than halfway through. Next is how to find the slope if I don't give you a graph. If instead of showing you a graph that you can count physical steps up for the rise and steps over for the run, what if I just gave you the coordinates of 2 points on a line and asked you to find the slope? Is there a way that you can find the slope of that line without actually making the graph? Suppose that I tell you that these 2 points lie on a line, 0, 2, and 3, 0. How could I find the slope of a line that goes through those 2 points without having to draw the line and count the rise and the run? Well, what I can do is I can put those 2 points in an XY table as shown here. And then I can find the rise and the run simply by comparing the 2 x values to each other and the y values to each other. For example, on the left side of this table in the x column, to get from 0 to 3, I'm going up by 3 steps. That says that my run is 3. On the right-hand side of this table, in the y column, to get from 2 down to 0, I'm going down 2 steps. So my rise is -2. My rise is negative because I would be going down to get from one point to the other. Now I have numbers for the rise and the run that I can plug into my slope formula. The rise is -2, the run is +3, and the slope is equal to the rise over the run. If we substitute numbers for rise and run, we'll see that the slope is -2 over 3. This is the same as -2/3. So we were able to find the slope of the line without having to do any kind of drawing of the line itself. We can see that this line has a negative slope, and so it would slant downhill. If we imagine a person walking along this line, they would be heading downhill as they go from left to right. Now, I'd like you to practice. Below, I've given you the coordinates of 2 points, 3, 3, and 5, 7. Working in your packet, find the slope of the line that goes through those 2 points. Please do show all of your work, and you should get to a correct answer that the slope is equal to 2. If the answer you get for the slope is not 2, please do ask for help to clarify. Next, we're going to learn how to find the slope of a line just from its equation. So if instead of giving you 2 points on a line, I gave you an equation of a line. For example, below you'll see the equation 2x plus 3y equals 6. We learned in a previous lesson that if I graphed all of the xy pairs that are solutions to this equation, they would make a line. The question is, how would we find the slope of that line? Well, there are different strategies that you can use, and the first one that I want to show you is finding 2 points on the line and then using the slope formula to find the slope of the line. So step 1, and in your notes this is a good time to make a 2-column chart where on the left you show the steps and on the right you show the examples. Step 1 is to find 2 points that lie on this line. That is 2 xy